Section 10.4 has two different components that we're going to look at in it. One is measures of central tendency. That is how things sort of are centrally the same. And then measures of central or of variation, and variation is how they differ. We do this in our relationships all the time. So we get together, we talk with somebody, and the first thing we usually look for is how we're the same, things that we have in common, right? And you probably do it if any of you are dating, married, engaged, any of those kinds of things. That's probably how you decided whether or not to continue seeing that person. Do we have enough in common of the right things that it matters? But of course, we don't have anything in common in general as everything with that person. And so then later on, we start looking at where we vary, how our tendencies are different, and whether or not those are significant enough to continue a relationship, be it a friendship or something more. So we're going to look at this now in terms of data and how that works. And we're going to start today with the central tendency part. So there are three measures of central tendency we're going to look at. The first one is called the mean. This is also called the arithmetic mean. It's what you probably mean when you say the word average. And it's found by adding all of the values in whatever it is together and then dividing by the total number of values. So if you were to look at, for example, your homework average in this class, this is what you would do. You'd add all the homework scores together and then you divide by 12 or whatever it is. I don't think that's how many you have at this point, but whatever it is, however many. You divide by that and that would give you your homework average. So far, so good? Okay. The second measure of central tendency is called the median. The median is the middle value. And it's found by listing all the numbers in order, smallest to largest, or if you prefer, largest to smallest, and finding the one that's in the middle. Now, if there's an odd number of values, there will be one in the middle, and you're done. If there are an even number of values, there will be two in the middle, and then you would average those two. Right? There's a third. The third type of central tendency is called the mode. And the mode is the number or numbers that occur most frequently. Now you might look at all these and say, why does it matter? That first one's the one I've always done. That's the one that makes the most sense anyway. What good are the other two? So let me kind of give you a scenario where maybe averaging, the way you think of averaging, isn't really a good measure of central tendency. Let's say, for instance, you want to know how much, on average, a Walmart employee makes. You're thinking about working there. You want to know if you should work there. You're trying to make that decision. If you took all of the salaries of everybody that works at Walmart, so let's say hourly salaries, just so it makes sense, and you added them together and then you divided by the number of people, you might end up with a number that's much higher than what you would really be making if you started working at Walmart. Because you might end up putting in there the president, or maybe the 2 or 3 store managers who make significantly more than the hourly employees, the cashiers, right? That wouldn't be a very good, average to make your assessment out of. It might make a lot more sense of lining them up in order from smallest to largest and saying, how about that person in the middle? Where do they fall? That's a better average for me. Or maybe it really just makes more sense for you to say, what about all of the people's salaries, hourly salaries, and you say, oh, look, 75% of the people who work there make $10 an hour. I'm going to make $10 an hour. That's really the best choice, and that would be the mode. How many of them occur the most frequently? Okay, do you see what I'm saying? It doesn't always really make a lot of sense. Like, so with recent events, if we did this with recent events, teacher walkout stuff, and you did look at averages the way that I just talked about at the beginning, you'd have to add in the superintendent and the principal. That might not be what we were really looking for, right? Or maybe you end up maybe you're looking at a particular school where most of the teachers have been there for like 20 years. Well, you're not going to be there for 20 years when you first start, so your information is going to be sort of skewed, and that's an actual mathematical word for this too. It's going to be skewed in a way that doesn't really fit what you were looking to answer. Okay? So it's not always reasonable simply to find averages the way you've thought about averages in the past. So we're going to practice doing the three things that we have said, finding the mean, the median, and the mode for these numbers. So we'll do mean first. That's the one you guys are most familiar with. What do I do to find the mean of a set of numbers? Yeah, we're going to add them all together and then divide by how many we added. So you need to do one of two things for me. One option is to write down what I'm writing down right now, where you physically show that you're adding them all together. And then how many numbers are there here? 7? I think there's 7. What is the sum if you add everything together on top? I don't have that number written down on my paper. 139. So I need to see either this or this. I need to see one or the other to show that you've got some data in there that you're interpreting how to do this right. And the primary reason is because if you jump from nothing to the answer at the end and you've made a mistake in your calculator, I have no way to know why you made the mistake. Did you make the mistake because you left a number out? Did you make the mistake because you divided by the wrong thing? I mean, where does the mistake lie? I can't give you any feedback that makes sense. So what is the value you get approximately, if we need to, when you do this division? What'd you guys get? Okay, let's go with a little bit more. What do you get if you use one decimal? I think it's a little less than 20, isn't it? 19.9. Let's go with one decimal for these. So 19.9 with one decimal of accuracy would be our mean. If we did median, I always have the picture when I'm doing median of you taking all your children in your classroom and like putting them in height order. Don't do weight. That would be that's not okay. But height's pretty okay most of the time. The littlest one, the tallest one might be a little uncomfortable, but people do this all the time. So you put them in order of their height and you find the person that's in the middle, right? So we need them to be in order for that to make any sense. So we need to either start with the smallest or largest and write them in order. So I'm going to go smallest to largest. What is the smallest number of this list? 12. And then 17. 18, 18, and if they are listed twice, list them twice, and then what? Fabulous. Okay, on this list, there is exactly one number that's in the middle, because there's 7 numbers. What number is it? 18. It's actually the second 18, so the median would be 18. And again, the only way I can know if you're doing it right is for you to actually write the list out for me, smallest to largest. So please show me that work. The last one is the mode. There's really not a lot to show for this one. Mode is the number or numbers that occur most frequently. So, what's the mode? 18 and 22, and that would mean this would be considered bimodal. There's 2 modes, okay? So we could have a bimodal or a trimodal set of data. Now, I've got a couple of application problems. So this Hannah that's at the back was asking me questions about your presentation, and I talked about the fact that this kind of a problem, for example, would not be a good presentation problem. This is just data entry, grinding out numbers. It doesn't have any application. It's not an enriching or exciting problem. This is it's boring, right? I mean, I need to know how to do it, but it's not a very engaging problem. The next two problems are examples of something. Please don't use these two because that's not appropriate. But these would be actual application problems of this information. So something that's a little bit off the mark. It's not a direct, like, here's a formula, do the formula kind of problem. So let's take a look. The mean is score. Remember, mean means like average the way you thought about it before. On a set of 20 tests is 75. What is the sum of the 20 tests? So I'm going to write out in language how we calculate mean. We take the mean to be what? What's in the numerator when I do mean? Yeah, and that's called the sum. So it would be the sum of the test scores. Right? Like if I were given a list of 20 test scores, I would in the numerator add all the test scores together. And then what would I be dividing by? Total number. Yeah. So this would be the total number of scores or tests or however you think about it. But it's the number of them. How many do I have? Now, you know two of these pieces of information. It just doesn't happen to be both information pieces on the right-hand side of this equation. Which of these three pieces of information do you know? Yeah, you know the mean and the number of scores. And as long as you know two of them, you can find the third. The mean is what? 75. I need a sum up here, so I'm going to just put that right there. And then what is the number of scores? 20. So what would I do then to find the sum? Right. I would multiply the 20 to the other side by the 75. And what would the sum be? 1,500. Now, I kind of hope you're looking at that and you say, well, why would I ever want to know the sum of the scores? That's really not something I care about. I don't really care about the sum of the scores. I might care about the average score. That would be useful, but they gave me that. So why would I care about the sum of the scores? Well, this was a problem sort of building up to the next one. This is not a very exciting or very useful kind of problem standalone by itself. But it gives you an idea of how to process through to the problem number 3. So let's look at problem number 3. And we don't have any boys in the class this year. Occasionally I'll have somebody in here. This is a football question. Not really, but it's talking about a football team. It says the mean weight of 7 linesmen on a team is 230 pounds. And the mean weight of the 4 backfield members is 190 pounds. What is the mean weight of the 11-person team? Now, we could take those two means and we could add them together and divide by 2, but somehow there's something about that that doesn't feel quite right. Any guesses as to why that wouldn't feel right? Why would it not be appropriate to do that? There's 11 of them.
It doesn't account for like the 2 extremes.
Okay, there's some extremes going on. There's something else that's related to both of those ideas.
What was it?
My question is, why does it not make sense, or why would it not be appropriate to simply say that I need to take 230 plus 190 and divide by 2? Why is that not okay?
130 is between 7 people and the 190.
You got it. So the 230 is because I have 7 people that average that weight, and the 190 is that I have 4 people that measure that weight. Now, if they both had the same number, now that doesn't work very well since 11 is an odd number, but let's just pretend I had 4 people in each of those categories and I wanted to find their average weight, then I could do that. That would actually be okay. But because I have 4 people who average one weight and 7 people who average the other one, that doesn't work. Okay, does that make sense to everyone first? Okay, so this is not the right approach. If you wrote this down, please do what I just did and mark it out so that you remember later that that's not what we're going forward with. Okay, so if I were looking at the average of these guys, their mean weight, I would have their total weight, and I would have the number. You guys know that's not really a hashtag, that's a number symbol. I keep trying not to write it because I know it's been like abducted and turned into something else, but number is what it means. The number of players. Okay, this formula looks just like what I did over here, right? Sum on top, total number, and gives me the mean. Well, I know 2 of these 3 pieces of information for each of these groups of men. Let's do it for the 7 linesmen first. What numbers would I put and where to find the linesmen here?
230 equals X over 7.
Okay, does that make sense to everyone? This would actually get me their total weight. Like I told you over here, why would I need to know their total sum? That seems sort of weird. Well, I'm going to use it here to finish this particular problem and answer another question. I could find their total weight then by multiplying by 7. So what is the weight of my 7 linesmen if I combine them? You know, I put them all on those like scales that they have at the Science Museum. Has anybody seen those? My son, my daughter, and I weigh as much as a cow or something like that. It's a fun scale in the Science Museum. What is 7 times 230? 1610. Fantastic. Now let's do the same thing for our 4 backfield members. So I have their mean. What is their mean weight? 190. And just so that it doesn't look the same, I'll call it Y on the top. And how many of them are there? 4. These are the faster guys because they weigh less probably. I mean, that's usually how that works. And then I would multiply by 4 to get the total weight of these 4 members. And what would I get? 760. What do you suppose I might be able to do with those pieces of information now? Yeah, I can actually find the mean of the whole team. I can add those 2 total weights, 1610 and 760. And what would I then divide by? 11, because I have 11 men represented there. What do I get when I take 1610 plus 760? I didn't write that down either. Fabulous. And what is that if I divide by 11? And did you give me a unit, Shelby? Pounds. Good. Pounds is LBS if you aren't sure. So the average weight of the football player, each football player, so to speak, on the team would be 215.5 pounds. Now, let me give you an application of this that you could actually be using if you needed to. You guys have to make a certain average test score in order to pass this class, independent of your actual average in the class. Are you familiar with that? I hope Dr. Marsh has talked to you about it. I know I probably don't talk as much as I should about that in my other classes either. What's that number? 70%. You have to have a 70% test average to pass this class. So let me flip to a blank screen and we're going to just give an example that's a random one. Okay. So let's say, for instance, on the first test, you kind of forgot the redo thing and you weren't really sure how important it was and you kind of blew it aside and you just didn't do as well as you wanted, and all of a sudden you had a 55 on that test. Not good. And man, you totally got your act together for the second test and you ended up with an 80 because you finished everything you needed to do. You didn't do great on the test itself, but you got all the redos done, so now you got an 80. And then the third test conflicted with something else, and you ended up with a 72. And you have 4 tests in this class, right? And you bounce back a little bit, and you end up with a 75 on the 4th test. These are made-up numbers, but pretend. You would have this going into your final exam. You'd know your 4 numbers, right? Well, what we want to know is we want to know what would I need to actually get on the final to make sure that I don't have to repeat the class because of test exam average. Everybody with me so far? Okay, well, the final exam has 2 exam grades because it's worth twice as much as your other exams. I believe that's true for your class. It is for my class that has the 4 tests. It's like this one, geometry. So there's 2 tests, if you will. They're the same score, right? X and X because it's the final exam, that also get averaged in there. And this is a total of 6 grades. Agreed? And you need this to equal what? At least a 70 in order to pass the class. All right, so somebody grab a calculator. Add for me my numbers together that I made up. 55, 80, 72, and 75. What do I get so far on top? 282? Okay. And then there's 2 X's up here, and there's a 6. I can multiply my 6 to the other side. So that's 420. What would I do to solve next? I know it's been a while since we've done a lot of algebra, but subtract the 282, that's right. This is what you guys do when you come to my office and say, what do I have to get on the final? I did a calculation like this for one of my online students the other day. What's 420 minus 282? 138. And then what would I do next? Divide by 2. And if I took 138 divided by 2, what would I get? 60 what? 9. Okay. This tells me if I get a 69 or better, I totally made all the numbers up right, but this if I tells me if I get 69 or better on the final exam, I will have that 70 average and I'll be in the clear for that. But if I get a 68, I won't. Do you guys see how it works? So this has direct application outside of my football linebacker kind of question to how we think about test grades in this particular scenario. Cool, right? All right. We're going to stop there today. We will have measures of central tendency, or not central tendency, variation when we come back next time. We have quite a bit on that one that we will start in on variation.